Hi everyone, I am Rahul. Welcome to my YouTube channel. In this video, we will see how to integrate the GitHub repository using Terraform Cloud. So what is Terraform Cloud? Terraform Cloud is a Hashicorp's managed service offering that eliminates the need for unnecessary tooling and documentation to use Terraform in production. With Terraform Cloud, we can provision the infrastructure securely and reliably in the cloud with their remote state storage capability. And as you scale the application, we can add more workspaces for better collaboration with your team. And also, Terraform Cloud provides a version control integration where we can use version control to store and collaborate all the Terraform configurations. So in this video, let us see how to connect our GitHub repository to a Terraform cloud. Let's dive in. Start with a new repository called Terraform Cloud Learning. I have cloned the project. So I have added the required code in there. I have added few Terraform files and I also have a profile generator lambda code. So let us start with the main.tf. So main.tf basically describes what the required providers are. Here I am mentioning it requires a AWS provider and I have provided the region and the profile and the shared credential file. So we give those values in the variable.tf. If you see the variable.tf, we have mentioned the region and the AWS profile and the shared credential file and the tags. Here I have a lambda.tf where I have used a module provided by AWS, which is AWS Lambda module, and here I am mentioning the function name and the description, and the handler is index.handler, and also the source path and runtime. If you see source path, it will be under resources slash the folder name. So if you see, there is a resources and this folder name whichever we have mentioned in source path. In that, it is looking for a handler with index.handler. So this is my handler code, index.handler. So this is the handler class where we have the faker dependency and we are creating a first name, last name, phone number. Now let me push the code to GitHub repository. So git push I will do. It asks for username. Let's put username and the password. And now what it is doing is it is writing the objects and it is pushing the code. Now let's go in this repository. Let us refresh now. Now you see the code is pushed into GitHub. Let's log in into Terraform Cloud. So let us click on start from scratch. Then we need to give a organization name. Let me give Rahul Learning and we have to give the email address. Then you have to create a new workspace. Okay, workspaces are like collections of infrastructure. It is similar to the directories. So workspace contains everything that Terraform needs to manage. So we want to choose the workflow which is version control workflow and then connect to GitHub. So here it shows that we will be connecting to this project from the GitHub repository. Now click on the create workspace. So once workspace is created, right, what we have to do is we have to create the variables which are required for our application. So what is required is, so we already have this AWS profile which is Rahul admin. If we want to change, we can change it, but let us see how we can use the Terraform variables. I'll not change, but I'll keep it same. Then the save variable and then add an environment variable where we need to add access key and secret ID. So let me add those. So I have added the AWS access key ID and AWS secret access key and the AWS profile. So now what we need to do is let us click on overview. So we have configured our variables. Now we have to run the plan. So let's click on this action and click on start new plan. We can give some reason for starting this plan. So let's give it as initial deployment and then click on the start plan. So what it does is it will check what all resources it can provision. First of all, it will connect to my AWS account and then check what all resources will be deployed. So once the plan gets completed, it will say that 7 resources we need to add and we need to check what all resources is being added. So if you see this plus, right, that is create. So if you see here for our module profile generator lambda, it is creating IAM policy and CloudWatch log group, and then what it will do is it will attach the policy to the role, and then it will create a lambda function where we have given this function name and handler. So once you are ready and the plan looks okay, what we need to do is we need to confirm and apply. So we need to give some comment here, initial apply. Now click on a confirm plan. What it does is it will provision the infrastructure on a AWS. So let's log in into AWS. So go to AWS console and then sign into AWS console. So you can log in into IAM user. The account ID is this one. So let's sign in. So once we sign in, right, let us see whether the apply is completed or not. So it is still applying. So once apply is completed, we can see the resources which will be in the AWS console. So now what it is saying is it is applying these things. If you see this, it is creating one by one. So if you see, all the things are created. So lambda function is still getting created. Once it is created, we will be getting a lambda function in our AWS management console. So let us see if it has created a role. So let's go to role, IAM role, and check whether it has created the resource or not. So login into IAM. If you see these roles, so let us see. So now it says that apply is finished, so we can see lambda function also. So if you see IAM role, this is what it has created, profile generator lambda. So if you see this here, IAM policy for profile generator lambda, and if you see the lambda, let us see the lambda code. So click on lambda. Now if you see function, we have this function profile generator lambda which had been deployed by that Terraform Cloud. So now let us test something. We don't need any events for this. So let's give empty event Terraform Cloud sample. Let's create it. Now test it. Now we can see that body has been printed. So this is how we deploy the code. So basically we create a workspace in the Terraform Cloud, and then it runs the plan and then applies the plan. So if you want, you can see all the things here, what all things it has applied and what all things has been provisioned. So it will give an overview, and then you can go to states. Here is where your state will be stored. Okay, this is important because this is the state by which it will compare when we push something in next time. So in variable section we have created these variables, and then we have this overview. Okay, so we have seen how to provision the infrastructure. Now let us modify something in our code and then push it. So before pushing it, let's see how we have to do some settings here. So if you go to settings, then click on version control. So once you click on version control, it says that automatic speculative plans. Enable this and then the branch from which to import. This defaults the value your version control provides. So let's click on automatic speculative and then click on update VCS. So once it is updated, now suppose let us do some changes in the code. Let us, instead of giving our lambda function, let's change this. Let's see, we have changed some code description of the lambda function. Now let's create a branch, git checkout -b new branch. So now we are on a new branch. Now let's add those and then give a commit, change the description, then git push it. So we have to push the new branch. So let us push the new branch. Now the new branch has been pushed with some changes. So now if you see the new branch, now let's compare and create a pull request. So we can give the main and the compare branch. Let's create a pull request. So what this pull request will do is, it will again go to connect to Terraform Cloud and it checks what are the changes we are getting from the commit. So what it will do is, it will, if you open the Terraform, it says that it is running. So whenever you push code in some branch and then raise a pull request, what it will do is it will create a plan again, so that we can check the plan again, and then it just gives a speculative plan. So when you merge a code into master or main branch, that is the resources it will provision. Those things we can check in this. So one to add, one to change. So if you go to GitHub, back to GitHub, what it says is, let me refresh this. So what it says is, if you go to this details branch, we can get the running information that plan is finished. Now we can see what has been changed. So here is what the change happened. So now if we are good, what we have to do is, we can merge a pull request. Now when we merge a pull request, what happens is, again a branch so when you push the code, merge the code into master, when you merge the code into master, then again after merge it will run a plan. So once plan is finished, what we have to do is, we can apply as we have done earlier. So let us wait for it to finish the plan. Okay, now plan is finished. Now we can confirm and apply. Merge the new branch to main. Now confirm plan. Before it runs, let us see the description is generates a new file. Okay, let us see once it gets applied. So if you in plan you see it was a generate new profiles and it was changed to generate a new profile changed. So that is what should be reflected when we apply this. Let us restart. So as the plan is finished and we have applied the changes, it says that plan has been finished and one resource has been created or changed. So what we can do is if you go there here in AWS, then refresh it, you can see the description will be changed. So if you see this has been changed. So this is how we can maintain the infrastructure even if multiple team members are working on a same repository. So one more thing is, so in this in this workspace what we can do is we can destruct or delete all the resources which has been provisioned also. So there are two options. One is to destroy plan. What it will do is whatever plan is there it will destroy. So when we do manual destroy, what it does is it destroys all the plans, all the resources which it had created. So let us destroy it. Now again this plan will run, and we have once the plan is run, we have to apply the plan. So if you see apply plan has been finished, so you can see 7 resources can be destroyed, would be destroyed. So now let's apply this, destroy the resources. Now click on confirm plan. What it does is it will destroy all the infrastructure it has provisioned previously. Now you see that it is apply has been finished, the 7 resources has been destroyed. Now if you go to the AWS console and you see the function, it's gone because it has deleted. So now this is what we can do. So one more thing what we can do is we can destruct this workspace also if we do not want. If we want to try few features, right, we can delete the workspace also. So to delete workspace you can click on delete from Terraform Cloud workspace. So now paste the workspace name, then delete the workspace. What it will do is it will delete the workspace. Now you see it will be like what we have seen earlier. This video we have created a GitHub repository and also saw how to create a infrastructure using Terraform Cloud. We also saw how to raise a pull request and check the plan, and then when merge happens the resource will be provisioned in AWS. Thank you.